Okay, I started recording already now. So basically what we are going to treat in this particular one is numbers, strings, printing, list, dictionary, boolean, tuple sets, comparison operators, then if else statements, for loops, range, list, functions, lambda expressions, map and filters, and methods. I believe that's actually all you need to know about Python to call yourself a complete Python developer. So basically, numbers is just 1, 2, 3, like adding them together, multiplying them together, dividing them, raised to power, modulo. If you don't understand any of these things I've run, just let me know, because I'm assuming you have a background.
Yeah, is the modulo that sometimes I don't get it, but sometimes
Okay, the
I still get
modulo
it.
is just basically when you divide a number by a number, the remainder, so that you won't get decimal place. That's what modulo is doing. That's just the basic thing about modulo. Do you get it now? Okay, for example, when you divide 5 by 2, you know the answer is 2 remainder 1.
Yes.
So modulo will give you the remainder instead of what you should get, Gogon.
Okay.
So something like, if you say something like 10 divided by 8, it should give you, 10 divided by 8 should give you 1. But when you say 10 modulo 8, it will give you 2. Because 10 divided by 8 is 1, remainder 2. So it is the remainder the modulo will give you. So do you get it now?
Yeah.
Okay. So that's under modulo. Then there is, I don't know if you know board mass. When we're in primary school, they used to teach us something like board mass, bracket of multiplication, board mass. Division, multiplication, addition, subtraction, like that. So that range of board mass is what arithmetic in Python to follow. So it's better to always use your bracket in case you have a complicated distance that you are writing. So that's that on that. So variable assignment is the next. It's just like giving variable name. So the basic thing in giving variable name is just you have to start with an alphabet or an underscore. You can't start with a number, and there are some reserved signs in
functions.
Yes, there are some reserved signs on the keyboard that you can use in your variable name, and there can be space. So you can use percentage in your variable name. You can use all these our arithmetic operators like addition, subtraction in your variable name. Instead of any of those things, you can use underscore, or you can use capital and small letter. Python is case sensitive, so you can easily switch from one to the other. So that's that. So x equals 2, y equals 3. So z equals x plus y. If you print out z, it will give you 5. So that's basic of giving variable name. Then strings, you can use single quote for strings. String is just like name. You can even use number in strings too, but make sure you quote it. So you can use single quote, you can use double quote. So that's basically what I explained here. Then printing. So printing is just basically, I think we are not using Jupyter Notebook now. If you are using the normal
VS Code.
VS Code,
or I should have preferred the VS Code also.
The reason why I did it like this. The reason why I did it like this is, for example, if you run any code, you see the response underneath it. So probably I send you the script now. If I send you the notebook now, if there's any problem with your own code, you can easily see, oh, this is what this person is doing, and this is what the response is supposed to be. But if I use something like VS Code, you can't see my own result. So you can't check it with your own. So that's why I'm using this. Actually, on the long run, I will actually use Spider. For example, I'm writing some code on Spider here. You can see you can't see my Spider. It's only the screen I'm sharing with you that you would see. So I'm actually working on some codes that I'm using Spider for. So I use Spider most of the time. VS Code is when I want to do probably website or something. But when I'm writing just basic Python code, I use Spider. So print operator, I know you understand print already, so I don't need to dwell too much on it. So list, do you understand list? List in Python?
Yeah, the numbers in the codes.
Yeah, and no, square bracket is what we use to do list.
The list of numbers in the bracket.
Square bracket. No, there are different types of this thing. There's list, there's set, there's what's it called now? Dictionary, there's tuple. So the one we use bracket for is the tuple. Don't worry, when we get there, we explain everything. So list is square bracket, like the square bracket. If you see my bracket here, it is square bracket. So the list is the one we use square bracket. square brackets like that. List is just, you can have numbers in your square bracket. You can have a list in your square bracket. You can have a tuple.
Can this be zoomed out or something? Okay. Can you zoom it out?
Let me check. Let me check. View. Let me check my view. I should be able to I should be able to increase my font or something. Okay. Can you see it now?
Okay. Yeah.
Okay. So square brackets is what we use for lists. So we can have numbers in list. We can have string in list. We can have what else? We can have list inside list. We can have tuple in list. We can have dictionary or set in a list. So whichever one. But I will just show you. I'm explaining list here. So when we get to tuple, I will explain tuples too. So let me just explain this. So list is basically what you use square bracket for. Like you want to bring together a set of strings or a set of integers, or you can bring integers and strings together. So you can use list for them. So for example, if you want to add something to a list, for example, we have this, my list, we call it ABC. So if you want to add a new variable to a list, you can just say append. So if we append D to the list now, and we print my list now, you can see D at the end. We've appended D to the list. So that's that on list. So we can call lists by their position. For example, in Python, we start counting from 0. So this position 0, this position 1, this position 2, this position 3. So if I want to call A now, I have to call position 0. You can see it's just A is giving me. Position 1 is giving me what? B. And then we can say from 1 to the end. So for example, that's what we are doing here with this colon sign. This colon sign, that's what we are doing there. With that colon sign, we are saying from 1 to the end. So we can say from beginning to 1. That's what we are doing here. But that beginning to 1 will not include 1. So from 0 to 1. For example, I say this now, you can see it's just A is giving me. If I change this to 2, I change it to 3 now. You can see it's giving me 0, 1, 2. It won't give me 3 with it. But if we start from 1, you start from 1 itself, it won't pick 0. So that's basically what we are doing with this colon sign in this our list. So then my list 0. So we change what is in position 0 to new. So if I call my list now, you can see A as disappeared, it has changed to new. So we just change what is in position 0 to new. Though all these things will be used when we start doing the actual operations in our data analysis and the likes like that. So here is another one. Next equals 1, 2, 3. Then we put a list in it. This is a new list now, but it's taking position what? Position 3. That's 0, 1, 2. The position 3 is taking this. Then mind you, when you call position 3, it will give you the whole of this, not just 4. So it will give you the whole of, so when I go that, so you know, next one should give us just 2. That's 0, 2. But if I call position 4 now, you can see there's no position 4. That's 0, 1, 2. Because all this list is just one position. So if I now call 3 now, you can see it's giving us just this list now. So what if I want to call something inside this list? So that's what we did here. So we call position 3, then position 2 in position 3. That's what we are doing here. Position 2 in position 2. You know, this is a list. So we are now going inside the list. I don't know if you get what I'm saying. The list inside the list is what we are calling now. So we are saying position 2, that's 0, 1, 2. So it will give us target. So now if we now say position 0 inside position 2 inside position 3, that's position 3, which is this one. Then position 2 inside that is this one. Then position 0 inside that position 2 now is now the target inside it. I don't know if you get it. So if I call this now, it will just give me the target, not the list. It will give me what is inside the list. Then dictionary. Dictionary is what we call key value pair. What I mean by key value pair is you give it a name, then you call the item in that inside in that position. You know, in list we are using 0, 1, 2 as our position, but here our position has its own name. So for example, we have said key 1 equals item 1, key 2 equals item 2. So if we run this now, if we print D, you can see it's giving us the dictionary again. And mind you, we use curly braces for dictionary. That is when between list and dictionary. You know, we use square bracket for dictionary. Here we use curly braces, like the curly sign. The way you use shift and the square bracket on your keyboard, square bracket is just you pressing without shift. We now use shift with it to give you curly braces. You can try that now on your keyboard. You see to give you curly braces instead of the normal square bracket. So that's that. Then to now call the position inside the dictionary now, we just call D key 1. Key 1 is the key, and this is the value. So we call D key 1 now to give us item 1, which is the value of key 1 in the dictionary. So that's that on that. The another variable type in Python is the Boolean. Boolean is just as is the smallest data type in Python. It just has two things inside it: the true and the false. But mind you, start with the true and the false with capital letter. So the true here and the false. That's it. If we let me add a new cell. Okay, you start cell below. So if I say type true, I'm not supposed to use capital letter. Type true. Type true will give us bool. That's Boolean. It's telling us our variable type is Boolean. So that's that on that. Then tuple now. Tuple is basically this. Tuple is okay. Tuple is like a list, but now we use the normal bracket that we use in mathematics. I don't know if you get it. The normal bracket, not the square bracket, not the curly braces. It is the square bracket we use. But one thing with tuple is we say tuple is immutable, meaning we can't add a variable to tuple. You can't add a variable to tuple. We can't remove from tuple. So if you are creating an app that you don't want them to add something to or subtract something from, you use tuple for that. So we can call positions. We use the same way we use positions in lists in tuple. So we can call position 0, position 1, position 2 like that. So here now, in list, we can easily say position 0, we want to change it to a new variable. But we try to do that here, it's not doable. To tell you, tuple object does not support item assignment. So we can't change the variable in a particular position in a tuple. So now we are coming back to set now. Set is basically the way we did set in okay, I studied mathematics. So the way we did set is just a set of variables that does not have a replica. In list, you can have more than one. For example, you can have more than 1, 2, you can have more than 1, 3, you can have more than one particular variable in a list or in a tuple or in a dictionary. In a dictionary. But when it gets to set, you can't have more than one particular variable of that particular thing in a set. For example, we use curly braces for set too. But the difference between dictionary and set is the way dictionary has key value pair, set does not have key value pair. It just have the values. So for example, here we have 1, 2, 3. You can see. For example, what if I tell you the set here is same thing as the set here? See, I have 1, 2, 3, 1, 2, 1, 2, 3, 3, 3, 3, 2, 2, 2, 1, 1, 2. But the thing in set is they are unique. For example, all these things that we have replica of, it will just change everything and just arrange everything and pick 1, 1 of each variable. For example, if I run this now, you see it's still 1, 2, 3. Even though I have more than 5 1s, more than 3 2s, more than 4 3s, to just give me one of them. It will just pick the unique ones and give it to me. So that's that on set. Then we now have comparison operators. The reason why I'm a bit a bit fast is because what's it called? What we are doing is a crash course, and we need to be able to hit our target in 4 classes. So that's why it looks like it's a bit fast. Of course, I'm supposed to be a bit slower. I'm supposed to use some other type of explanation than this, but we need to be fast. That's why I'm doing this. So comparison operators is just we are comparing one particular value to the other. For example, is 1 greater than 2? That's false. So you can see our Boolean is coming back here again. If you don't understand anything, let me know so that I won't just be assuming you understand what I'm saying. For example, 1 is greater than 2. It is false. So you can see our Boolean is here again. Then 1 less than 2. That's true. Then is 1 greater than or equal to 1? So you can see we have 2 operators there. We have 1 greater than or equal to. So if it's equal to, it is true. If it's greater than, it is true. So we run this now, it is true. We say 1 less than or equal to false. Is equal to 4. That is 1 less than 4? Yes. So one of them is true. So it is say true. So is 1 equal to 1? So you know we have assignment operator,
yes.
We have comparison operator. So here is an assignment, I mean, is a comparison operator. If we just use 1 equal to, that's an assignment operator. But we use double equal to the comparison operators. That is, we are comparing the left and the right. So here now it is true because you said yes to yourself. So that's that. Then is I equal to by?
No. False.
False. Exactly. Something like ṣé ẹ káàbọ̀, ó jẹ mọ́ ó dàárọ̀. That's, if you understand Yoruba well, that's basically what this person is saying. Yeah, so that's false. So logical operator. Logical operator is just basically adding and or. Okay, the thing with and or, let me crack a joke we used to crack with ourselves when I was in school. We used to tell ourselves, oh, if you tell a lady, I love you for better or for worse, it means you can love the person for better and not love them for worse, or you can love them for worse and not love them for better. But if you say, I love you for better and for worse, it means you have to love them in all circumstances, in all conditions. So you have to love them for better and for worse. So that's something with the and operator here. If this one is true and this one is true, it will give you true. If this one is false and this one is true, it will give you false. Once one of them is false, it will give you false in and. But in true, once one of them is true, it will give you true. So that's that on and or. So for example, is 1 less than, is 1 greater than 2? False. So automatically this whole statement give us false. Is 2 less than 3? True. But since this one is false, so this one will give us, the whole of this will give us false because one of them is false. So same thing with or now. Or will give us true whenever one of them is true. So here we give us true because 2 is greater than, is less than 3. So under or is here now. Is 1 equal to 2? No. Is 2 equal to 3?
No.
Is 4 equal to 4?
Yeah.
So if we run this, what should this give us?
Yes, it's true.
It should give us true. So that's that on that. So now coming down to if else statements now. So basically what we are doing here is we are checking for conditions. We are checking if a condition is satisfied, then give us a particular thing. For example, here now we are saying if 1 less than 2, print yep. Something like this, our comparison operator. So we are now bringing comparison operator into our conditional statement. So here now, is 1 less than 2? True. So if 1 less than 2, print yep. Something like when you design a game and you are like, if player A has higher score than player B, say player A wins. So that's something we are doing. So if you check the blackjack game, I sent the link to you, you will see exactly what I'm saying here in the one of the conditions I wrote in the blackjack game. So here now, this one will give us yep because 1 is less than 2. If I change this to 3 now, if I print this, it won't print anything. So that's, let me just change it back to 1. And because the condition we gave it is if 1 is less than, if this one is less than this one, print yep. So here's another one now. If 1 less than 2, print yep. So it's still the same thing. So it will give us yep again. So now, when we change this to 3 the other time, you know it's not printing anything. But for example, if you get a software, for example, and you start using it, and you run something, it's not giving you, oh, what you are doing is wrong. It's not saying anything. It will baffle you like, what is wrong? Am I doing something wrong or something? So for your user to be able to get a response like, oh, this thing actually has a problem here or there. That's why the else statement comes. So if 1 less than 2, print first. Else, that is, if 1 not less than 2, print last. So that's what this one is doing. But since our first statement is correct, it just give us first here. So here is under this thing now. If 1 greater than 2, print first. Else, print last. So what would this one give us?
If 1 is less than 2.
No, this one is not less. So this one is greater than.
Greater than 2. Print first, else, print last.
To give us last.
Exactly.
Exactly, to give us last. Then there's another thing. Let's say you want to check for more than one condition. Let's say the first condition is not met. For example, let's say, okay, you want to eat now. Let's say you are a vegetarian. Okay. If there is vegetable, like, okay, let me see one. Okay, if there's salad, give me salad. Else, if you prepare your stew without meat, give me stew. Else, okay, let me come back again. If there is salad, you are a vegetarian. So if there is salad, give me salad. Else, if there is soup without meat, give me soup.
Give me soup.
Else, I'm not eating. You know, there are two conditions there. If the first condition is not met, give me the second condition. That's exactly what we are doing here. So if 1 equal to 2, print first.
Yes.
1 is not equal to 2, so it can't print that. So else, if 3 equals 3, print middle. Else, print last. So what would this condition, what would this give us?
Print middle.
Print middle. So it will give us middle. So that's what this one is doing for us now. So you understand conditional statement now. If statement, if else statement, I mean else if statement and else statement. You understand them?
Yeah.
So far, is there anything you don't understand in everything we've done?
Yeah. Move on.
Let's go on. Okay, let's go on. Okay. Then there is for loop. So this is where, okay, for example, you can see list here now, the way we had the list the other time. So this, we say sequence equals list. So for item in sequence, print item. So basically what we are doing here is we are looping over that list. So we are saying for item in sequence. So this item will take a particular position. So you take position 0, position 1, position 2, position 3, position 4. Okay, we have just 5 items. So it will take position 0, 1, 2, 3, 4. So that's that. So now we are now telling it for item in sequence, print item. So we are telling him to loop into the sequence now. This is the sequence in this list. This is the list. So we are saying, okay, item take position 0. Print what is in position 0. Then take position 2, position 1, which is 2 here. Print what is in position 1. Take position 2. Print what is in position 2. Take position 3. Print what is in position 3. Take position 4. Print what is in position 4. So that's basically what we are doing here. So if we run this now, you can see first position is printed 1. Second position is printed 2. Third position is printed 3. Fourth position is printed 4. Like that. You get it? So now, instead of we print what is inside this list now, here we are saying for each position, print yep. You can see position 1 printed yep, position 0 printed yep, position 1 printed 1, I mean yep, position 2 printed yep, position 3 printed yep, position 4 printed yep. So when the list is exhausted, it stops printing. So that's what we use for loop for. So we use it to loop over a sequence. For example, I can say for, okay, let me do something else here. Let me use range 10. So if I say range 10 now, it will print take position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So you can see yep now. If I say print item, you can say, see it's printing 9. So you don't necessarily need to use item. You can say I, you can say X, anything you like. For example, you use I here, but you can't use a number. So you can see for I in range 10. Wait, it's printing just 9. Shouldn't print just 9. Why is it printing just 9? Oh, I'm saying item, sorry. Supposed to print I. You know, the last thing item took the last time was 9. That was why it's printing 9. So if I print it now, I'm printing I, not item again. I don't know if you get the mistake I made.
Yeah.
You got it. So let me just change it back to what we add. Let me just leave the range item. Okay. So now for jelly in sequence, print jelly plus jelly. This is where we start using logic with our for loop. I don't know if you see what I'm doing here. For jelly in sequence, this is the sequence. 1, 2, 3, 4. So print jelly plus jelly. So what would it print for me? Just think about it. Let me open, let you see. Okay. So this is the sequence now. I'm saying for jelly in sequence, print jelly plus jelly. So what was the first thing to print?
For jelly is sequence, that is 0 to 1. That is 0, 1, 2, 3, 4. For
So what's first in
jelly
sequence?
is sequence. Print jelly. It will print it will print 0 plus. No?
Okay, get it. Let me explain what this thing is doing. It's not taking value 0. Jelly is just the position. So it's taking the value in the sequence. So position 0 in this sequence is 1. Position 1 in this sequence is 2. So 2. What would the first thing this sequence for this for loop print out?
It will be 1 plus 0 plus 1.
No. The first position is 0. And 0's position here is 1. So
1
jelly plus jelly.
1 plus 2.
No, it will be 1 plus
1 plus 2.
No, get it. For this loop is like you are running around a circle. So when you are running the first time, jelly takes value 1. Until you come back to this loop, it can't change the value 1. So when it leaves here now, when it leaves this particular position, something like entering a room, the loop is like entering a room. So when you enter a room, you can't enter the next room until you leave that room. So now, once you enter the first room, that's position 0, your value is 1.
Which is 1.
So the printing will do 1 plus 1.
And 1 plus 2.
No, it will be 1 plus 1.
Because the position...
it will do 1 plus 1. Then it will leave the room, come back into another room. Then it will take the value 2. Then it will now be 2 plus 2. Then leave again, come back in. Then it will take position 2. It will now be 3 plus 3, like that. So that's if I print out this now, you see it is 2, 4, 6, 8, 8. So position 0 is 1. So 1 plus 1, 2. Position 1 is 2. 2 plus 2, 4. Position 2 is 3. 3 plus 3, 6. Position 4 is 5. 5 plus 5, 10. Do you get it?
Yeah.
Okay. So let's go to while loop. So we don't have much time because I need to finish this particular notebook today. We are almost done actually, though. So I'll give you an assignment, though. I'll give you an assignment. I'll show you the assignment. I'll send it to your mail. So that's that. So while loop now. Unlike for loop, we can use while loop too. But in while loop, we are checking for a certain condition. Until that condition is met, we keep going. No, in for loop, we are just checking through a bunch or a range of numbers, a sequence of numbers. But in while loop, we are checking for a particular condition to be met. So we are saying while we initialize I to be 1. So we are now saying while I less than 5. Sorry. Okay, while I less than 5, print I is, okay, we are using format here. So that's, we call it string. Okay, this is something we do in strings. So this format, I will just give you what is in that I to be printed here. So we could have said, let me just simplify this so that it won't look complicated for you. But this is the right thing to do. But this thing is more like saying this, then plus I. It gives us same thing. So what you saw the other time, okay, let me copy all of this. Let me now undo. Okay, this is what we call string formatting. Let me insert a new cell below. I'll insert a new cell below. So this and this is the same. It is just basic string formatting. So that I won't be using this addition. Like, imagine we want to write another thing at the end. Now, for example, here now I could have said correct. But if I want to do that correct here now, I have to say plus correct. You see, this one is more tidy than this one. That's why we use string formatting normally. So basically what we are doing with this string formatting is this curly braces, so take the format of I. And what is I? What is coming from this while loop? Do you get it?
Okay.
If you don't get it, let me know. Don't just do okay.
Yeah. We go over it again.
Okay. I should go over it again. Okay. String formatting is basically, okay, you know, when we're doing this one, we said print jelly plus jelly.
Yeah.
So here now, you want to print some other things with the thing we are printing. And we want that those things, okay, for example, now I want to say I is what? The first time this while loop runs, it will take value, I will take value 1. So I is 1. We want to print I is 1. Actually, if I run this one now, if I run this one, what is wrong? Okay, I'm supposed to convert this one to string. And this is another thing. This is another thing we are avoiding with the string formatting now. For example, if I run this one now, you can see I is 1. In the first time, I is 2, I is 3, I is 4. So I have to convert the integer to string first, then add it to a string. Like we are adding a string to a string. So that's what we did here. So here now, I want to.
Sandy.
Are you getting it?
Okay.
Yeah, I'm getting it.
Okay. So we added a string to a string here. So now in string formatting, instead of we converting this string to this integer to a string first, then add it to this. We can just add anything to our string, even if it's a list or a integer, a loop, sorry, I just a loop, a set or anything, whatever data type we want to add. We can just call it with this string formatting and add it to our string. So this thing is a string. Remember when I was telling you about string the other time, I told you a string has to be quoted, like single quote or double quote. Then so we are now adding a string that whatever the variable this our while is giving us, we are adding it to this string here now. So that's why we are using string formatting. That's basically how to use do string formatting. So we could have done the normal thing of adding string to it, or we can use string formatting that just at the end of the string, just put dot format, then the thing that is coming from here that you want to add to the string, just put it in this open bracket and close bracket here. It can be more than one actually. For example, I could have said under curly braces here and just say comma I again. So we are adding I twice. So if I run this, you can see I is 1, correct I, like that. But let's just get back to what we're doing normally. So here too. So if I now run this, now I can see I is 1, I is 2, I is 3, I is 4. Do you get it now? So that's on that. Then range, I've used range once already. I used range in our for loop here. Where is it? Okay, I used range here. So range is basically just getting a set of numbers.
Take a value from here to here.
Exactly, you get it. If value from set of value from here to here. So if I say range 1 to 5, I could have said 5 to 10. Okay, 5, 10, sorry. Can say range 5, 10. If I now say print range 5, 10 now, give me 5, 6, 7, 8, 9. Don't print the last one. Range will not add the last one to it. Or better still, let's say you now want to have, let's say 5 to 100. If I say 5 to 100, now you can see it is too long. Let's now say we want to now be going in 5 interval, like want the common difference to be 5. We just say under comma 5. Sorry, what did I do now? Comma 5. Comma 5. So 5 intervals, that is 5 is a common difference. You can see it's now 5, 10, 15, 20, 25, 30, like that. So I could have said range 0 to 10 with common difference of 2.
So it will be longer than.
Exactly. So it will now give us 0, 2, 4, 6, 8, like that. So you can actually convert a range to a list. Just put list before it. So let me just. Let me just add insert a cell below. Then I can say list range. You know the way we're doing range 1 to 5 the other time. So list range.
Yes.
Just briefly.
So what's wrong? Type object not coming. Oh, sorry. I'm supposed to use open bracket and close bracket. I use square bracket. So 0, 1, 2, 3, 4. And again, another thing is, for example, you see, I've made some mistakes so far, and I'm able to correct myself immediately. And the reason why I'm able to correct myself immediately is because I've made those mistakes in the past. So practice makes perfect when it comes to programming. Yeah. So when you run into a mistake now, the next time you fix it, you might not be able to fix it as fast as I fixed my own. It might take you days, sometimes weeks.
Yeah.
But probably when you run into mistakes, so that it don't take you too much time, you can always reach out to me. But don't expect your own mistake correction will be as fast as my own. Because what I've noticed is people will now start comparing themselves to the person that taught them programming in the beginning. And they will now be like, maybe I'm not called out for this thing. Programming is not.
Although the main thing, another thing is how to be able to read errors and understand what they're talking about.
Exactly. For example, when I read my own error, I'm able to see, oh, this is the problem this thing is giving me, not this problem. So I'm able to just fix it immediately when I saw my mistake. So next time you run into any error, just read the error statement. The major thing is read the last line. This thing is the major thing. Read the last line, then check where this stupid thing here, where it's pointing to. That's where your error is. Or if it's a long set of lines of code, to give you the line number. So check the line number. If your code is long, then check what this thing is pointing to. Then check the last line. That syntax, it's giving me a syntax error now. Don't worry, we'll treat how to catch error too. Maybe before you release your code for deployment, for final use, you have to be able to catch your error. So that's that on that. So let me just close my bracket here back and run it. So now, list comprehension. So basically what we do with list comprehension is we want to bring in for loop into a list. So for example, see here now, I have x equals 1, 2, 3, 4 in a list. So now we said out. So for item in x, out.append item raised power 2. So basically what we are doing is, okay, x is 1, 2, 3, 4. So for item in x now, then our out is an empty list. So we're now saying out.append item raised power 2. That's basically the first time item will take value what? What is the value of x the first time it runs through this loop?
It should be 0.
No,
or
1, exactly. It should be 1. So then we're now saying append item raised power 2. So what will be append to out? What's the first thing that will be added to out?
Append, that is 1.
Yeah, exactly. 1
to the power of 2.
Which is 1. So the next time it runs through this loop, it will give us what again?
That will be 2 to the power of 2, which is 4.
Exactly. So now, mind you, the way we run code in Python, I've not explained this indentation thing. This thing is actually 4 spaces. Normally it's supposed to be 4 spaces. You can use more than 4 spaces, but it has to be consistent throughout your code. So yeah, this indentation is just simply telling us you can't go to the next line until you are done with this line. Something like you entering a room. Once you enter a house or a compound, you can't go to the next compound until you are done with what you are doing inside that compound, except you go out through the gate again. I don't know if you get it. So here is same thing now. So when you enter a loop, for example, a for loop or a while loop, you can't go to the next line until you are done with what you are doing inside that loop. Until you are done with what you are doing inside that indentation. So for example, here now, what oh, bless you. What you would have expected is print out this our out for us immediately. For example, if I run this now, you can see it printed out our final result for us. But if I actually indent this now, if I indent this and print, you can see it printed out 1 the first time it ran through the loop, Then printed out 1 and 4. The second time we run through the loop. Then 1, 4, 9. The third time. We have 1, 4, 9, 16. The fourth time. And the reason for that is why? Because this print is still inside this loop. And the first time we ran it, it was outside the loop. I don't know if you get me.
Maybe you go over it again.
Okay. It's something like when you are inside a house, let's say each house, don't let me use fine here. Each house has a tree inside it. So when you enter the house, you can eat of the tree inside the house. So the first house has just mango tree. Second has mango and orange. So the first time you enter a house, you can eat the mango. The first house, you can eat the mango and go out. So same thing here now. The first time you enter this loop, you have just 1 with you. So you raise 1 to the power of 2, which gives you 1. So when you raise 1 to the power of 2, it gives you 1. If you are not, this print is not part of the loop at that point. So you can't see what you have done. Then you go out again. You bring in 2. 2 to the power of 2 gives you 4. Then you add 4 to your list again. You append it to your list. That's you now have 1, 4. Then again, you come in again, you raise your 3 to the power of 2. It gives you 9. Then you now have 1, 4, 9 in your list. Then the next time you come in with 4. So 4 raised to the power 2 is giving you 16. So that's 1, 4, 9, 16. So by the time you now bring in all these things, you've exceeded everything inside this list here. So once you are done with everything inside this list, you can now leave this loop. You can now leave this loop and come to this print outside the loop. So you can now print out everything at once. Compared to when you have this print inside your loop.
So you just go out, give me what you have.
So you can print out whatever you have at each point.
Yes, go out, bring what you want, keep it for me. Go, bring what you have, keep it for me. Go again.
Exactly. So here you can see what you have, but here you can't see what you have until you are done. Do you get it now?
Yeah.
Okay. So here is, so everything we did here that took us 4 lines, you can do it in just 1 line here. So item raised to the power 2 for item in X. That's what we call list comprehension. So you are creating a list with this list, and you are raising each of the items to power of 2. So for item in X, raise the item to power of 2. That's basically what we are doing here. So for that's item in X, that's this X, we have 1, 2, 3, 4. Then raise it to the power of 2. So you raise 1 to the power of 2, you raise 2 to the power of 2, you raise 3 to the power of 2, you raise 4 to the power of 2. Then you are now putting it in this list. You know, here we have to initialize our list by saying house equals this. Then for item in X, append item raised to the power 2. For here, list comprehension will help us to shorten this our for loop to just 1 line. We don't need to initialize, we just need to create that list. This is the list, that's square bracket. Then we now raise each of the items here to the power of 2. I don't know if you get it. Do you get it? Or I should explain it again?
Yes.
Okay, so basically we just shorten what we have here to here now. So instead of having our for loop, our conditional statement of for called for,
we just have 1.
We just have it once here. Then we now say for, okay, raise everything to the power of 2 for each item in this list. Something like speaking English. So we having a compound statement, we have a simple statement. Exactly what we have. That's what we did here. So it still gives us the same result. So now we are now getting to the interesting part of our crash course. Now we are getting to function. For example, everything we did today, I assume you understand, but the thing is, you need to practice them. You've not gotten them because it's a crash course. I just had to rush so that we'll be able to get to where you want us to get to in the amount of time we have. So now, this is how to define a function. Now, basically, a function is just we have been all these things. You know, for example, if we want to call this for loop, the next time we want to call it, we have to come back here and rewrite our for loop again and the likes. And from what you told me, you want to have a program that can easily be called once and it does whatever you want it to do on the particular set of data you are giving it. So that's where function comes in. So function, so my func parameter equals default print parameter. So if I call this now, if I call my func, it just give me the function type and the likes. So basically, the way we define a function is we call define, we give it a function name, then we give it parameters that we want inside the function. Then we can set a default value for each parameter. So you can have more than one parameter sometimes. So here now, so for example, my func, it's just giving you the definition of the function. But if you actually want to call the function, you have to use open bracket and close bracket. So you can see it's giving us default, which is the default parameter. So if I now say my func new parameter, that is, you know, this parameter now, we're giving it a new value here. But here we are giving it a default value. It's something like a game. When you start a game, you're already in level 1. That's default value. But let's say you finish level 1, to promote you to level 2. So that is, it is giving the function a new parameter. So the level 2 will now go and call another function for you. So that's what we are doing here now. So new parameter. So we are giving this param1 a new parameter, which is what? New parameter. The name we are giving it is a new parameter. So what will this param1 give us? Print for us. Instead of printing default, we now print new param for us, which is this. Do you get it?
Yeah.
So that's on that. So the next thing is my func param1 equals new parameter. So for example, here we didn't call the name of the parameter, but maybe you have more than one parameter. You either give them the orderly arrangement, or you give it the name of the parameter equal to the for example, here we have param1, so param1 equals new param. Okay, I can say param1 equals Abbas, my name. So if we now call it param1 is already equal to Abbas, then it's printing out Abbas. So you can see this thing is saving us a lot of headache. So we're having to call all this again and write everything again. The function will just give it to us once. So for example, now let's now come to here now. We are defining square. You know, here we are squaring our for loop here. So we are calling square here now. So square equals, define square x, return x raised to power 2. So if we run this now, so raised to power of 2. So if we now say square 2, it give us what? It's telling me my internet connection is unstable. Okay. If we call x squared now, so if I now say square 2, it give us what? So if I print out, it give me 4. Actually, I wanted to say if I print out, they give me 4. So that's that. So we could have called this square. For example, let me bring in this our for loop here again.